Hello class. Alright, so today we're going to be finding the area of parallelograms. And as you can see, these are a little bit different than squares or rectangles. Different shape, and so a mistake a lot of people will make in finding the area is in thinking that if they just count down a side like this, that's going to be a side they can use to find the area with. And actually doesn't quite work that easily. Instead, what you're going to have to do is you're going to have to think about doing really one of two things. You can either take the shape and kind of rearrange the parts to where you have a rectangle. So that would look something like this. If you were to draw a line through here, and if you see the triangle to the left here, imagine that being flipped over to where we would end up having that over here, like this, coming down here. So this part would be gone, and you'd just be left with this part in here. Well, that would be a square or a rectangle you could use to find the area easily. So that's one thing that you can do. Another thing that you can do is just take what you have, the existing parallelogram, and enclose it in a rectangle that's bigger, and then just subtract the parts that are outside of it. So for instance, this part here, I'm going to leave it here. But what we could do is we could add in another extra side outside of the shaded region, and then we could take that and see that as one big rectangle. We could use that big rectangle to find the area. So for instance, if you had the height, if you count down 1, 2, 3, 4, 5, 6, right? That's 6. And then, so I could make a little note of that here. We'll call that 6. There we go. And then for the base on this side here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9. And so 6 times 9 would be 54. But 54 is not going to be the area because we would have to subtract these parts in here. If you look at these two triangles, if we combine them together, if we took this side, and had them together, that would be a rectangle. You'd have one side with 3, and the other side we said was 6. So that'd be a total of 18, right? So you'd have to take away 18 from that, and that would give you 36 square units. Okay? So either way would work for that problem, and either way could work for this problem, but some ways are going to be easier than others. I did want you to take a look at the manipulative here. If we click on this and then you scroll down, you have in 4.2 area of a parallelogram, you have the option to kind of manipulate figures here. You can kind of move them around. If you click on the green, on the red vertices here, that can help you move them around. You can play also with this figure down here. You can kind of stretch it out. You can see how it can become a rectangle like that, or you can move it back together. So that's for you to play around with on your own time. But within here, if you look at this one here, I think that, because it's so kind of scrunched together like this, it's going to be easiest to enclose it in a larger figure. So if we look at that, let's just go ahead and draw outside of it to where we can form a bigger rectangle and get the area of that bigger rectangle and then subtract the missing parts that are not shaded in to get our area of the shaded region. So if you look here, I know it's not perfectly straight, but the idea is that we have a bigger rectangle here. It's got 3 would be this side, and this side, if you count 1, 2, 3, 4, 5, 6, 7, 8, you got to count the outside parts, 9, 10, 11, right? So that would be, we would have 3 on the side, and then we would have 11 down here. So if we do that, 3 times 11, that's going to give us 33. But remember, we have to subtract these two triangles. So again, the one side is 3, and then if you count the other side, we're going to have 1, 2, 3, 4, and this one here is just kind of tricky, but it's 5 because that spot right there is one of them. So you're going to have 3 times 5. That's 15. So really, what you're going to end up doing is you're going to have 33, and then you've got to take away the 15 that's missing, and that equals 18 square units. Okay, hope this helps.